Last up is a fantastic panel. Come on up, panelists. It's one I've been waiting for on emotional analytics. It's about how we can actually understand sort of the next generation of information coming from these systems and design systems in such a way that we can incorporate how people are feeling throughout their experience. So I look forward to the wisdom of this panel.
Okay, so if anybody in the back can't hear me, please jump up and down and wave so we can adjust. But and it looks like nobody wanted to sit next to me, so no. Thank you. That's quite kind. My name's Josh Tucker. I'm a lawyer and probably the least interesting person up here by a fair margin, you'll find. But in chatting with some of my fellow panelists, I think you're going to be very, very impressed at the types and power of inferences that their systems they're building can draw from your data, and the types of data that they can that they're finding useful. I know I've been very impressed, particularly comparing and contrasting this community with, say, ad tech more generally. I've noticed a much higher level of rigor that, as a culture, seems to be applied within this group, and relative to some of the other technologies I work with, where people are applying maybe some of the similar algorithms, but I think this whole community should be commended for that. It's very impressive and refreshing. So I thought we'd begin with a brief introduction by each of us, and then get into a few questions that I prepared. I'm, as I said, a lawyer. I'm with the law firm of Pillsbury, Winthrop, Shaw, and Pittman, large general practice law firm dating back to the 1870s. Here in San Francisco. We have a virtual worlds and gaming practice that we're quite proud of, and I'm finding our machine learning and big data practice also for intellectual property. Just chatting with folks seems to be particularly relevant as well. With that, should we go down the line, have everybody introduce themselves, and tell us a little bit about what you maybe what your company does and how it's relevant to analyzing data from experiential technologies.
Sure. Okay, so first of all, thanks, Josh. Thank you all for coming. I mean, you're giving up your afternoon to come see us, and try to make this as interesting as possible. My name is Alexander Hawk. I'm the Director of Developer Relations for a company called Retinad. And what we're doing is virtual reality analytics. We're doing analytics for virtual reality. And what does that mean, and why should you care? So VR is this new medium. There's a lot of hype around it, and it just seems like nobody really knows what's effective, what's not so effective in VR. In terms from UX, directors, film directors, marketers, and just VR pioneers and developers don't really know what's working. So we developed this tool to allow these customers and these developers to understand what's going on and what's effective and really what's not so effective. So one of the first things we need to do in VR on the analytics side is understand, kind of proof through negation, so what's not working. And we've developed a couple tools to do that, which I'll jump into later on.
So my name is Fred Spencer. I'm with EaseVR. So we've built an experience analytics intelligence engine to enable adaptive experiences in real time.
Hello, my name is Patrick Hilsbos, and I'm CEO and founder of a company called Neuro. And we started about kind of like 6 years ago with the intention to kind of close the gap between wearables and kind of like people, kind of like starting from like signal processing, but more like focused on creating fully immersive audiovisual experiences that are interactive based on kind of like real-time biodata. And I think it was kind of like great. You also said kind of like why does it matter? And my personal intention behind that is to create a digital representation of kind of like psychological techniques, of kind of like mental techniques, kind of like digital medicine. Because I think currently, you know, like a doctor should be a teacher, but it's not affordable here in the United States. I'm myself from Stuttgart, like in Germany, and it's also not affordable there anymore. So I really have the vision, and I think, I really believe that we can make that happen if we collaborate and work together to create digital representation of teachings and then kind of just like stream them out there. If you need to be focused, just get some more focus. But maybe more important, if you're stressed out, just get some relaxation. If you want to sleep, just like go to sleep. And we already have all the technologies. It's like VR, sounds, visuals, and also all the variables to kind of like teach technology to really understand how we feel, where the analytics part also becomes pretty interesting. So I hand over to you.
Cool. My name is Tim Mullen. I'm the founder and CEO of a company called Cusp. And we come pretty much wholesale out of the sciences, computational neuroscience, cognitive neuroscience. And we created Cusp out of a recognition that the pace at which algorithms and analysis tools were advancing in the sciences was perhaps outpacing the applications that we see in industry. And part of that is the challenge for, say, a new company coming into the neurotechnology market of trying to engineer an end-to-end solution from a sensor through analytics all the way to an application all by themselves. And that can take years, and there's a huge amount of research and development involved in building algorithms that can decode your brain state, get rid of noise, and provide something meaningful that you can then start building your application on top of. So Cusp is really there to solve that problem through our middleware platform called Neuroscale, which basically is a scalable, cloud-based API platform for connecting to different devices that are out there in the world, brain sensors, other kinds of biosensors, and making sense of that data with machine learning, signal processing, very domain-specific tools based on expertise from the neurosciences, and giving that to you in an easy-to-use manner that you can then integrate into your application, build your application upon. And we also provide tools for being able to build your own pipelines and be able to do your own research and development, sort of connecting widgets together in a graph. And so ultimately, it's about closing that gap between the sensor and the application and providing a middleware stack that makes that possible.
Exciting. Great.
Yeah.
So my name is Peter Hotsz. I'm the founder and CEO of a company called iMotions. So we've built a biometric research platform that basically can combine a lot of different modalities such as eye tracking, facial expression, GSR, and EEG. So basically what we utilize all the companies and universities to do is to really get high quality data that they can work with and, for example, throw them up in this kind of cloud-based solution. So one of the big pains out there has been that people that have bought, this kind of hardware standing in the corner, and that another part of hardware that had 5, 6 computers running in order to try to synchronize these data. And there's no doubt that understanding the multimodal behavior of people, not only having one sensors like eye tracking or EEG and so on, is the future. So we need to understand much more on the human behavior side. So that's basically what we built, and it's being utilized now in more than 50 countries. It's an offline platform where people own their own data. So we have a lot of large corporations, Unilever, P&G kind of companies using it for shoppers' insights. We can also have eye tracking glasses on and synchronize that directly with EEG. So we also have usability, so you can test your websites. Are people getting frustrated? Is there a nose wrinkle? Whenever they come to a specific part of the site, can they find the buying button? We have a lot of researchers doing research on diagnosis of neurological diseases. So Alzheimer's, Parkinson's, autism, schizophrenia, all these kind of diseases. And it goes also across VR, where we actually have launched out here for the first time ever a real-time system that can live visualize biometric sensors while you are in a full immersion in a VR world. So it's really great because then you can suddenly see if now there's a simple roller coaster out here, but let's say somebody has a phobia for heights. There's really all of these kind of diagnosis of and helping and training people to get out of these kind of phobias will be great in the future. But if you don't know that the heart rate is going up, that they're getting more aroused and so on, how do you know how to help them? And also if the training and healing them gets better. So there's tons of different application areas. We also work with the car industry, a lot of car companies who want to build the autonomous car. We all know that. Is that going to happen or not? If it's going to happen, you at least need to have a lot more sensors in the car in order to understand, drowsiness and make sure that people, at least until they can drive completely by themselves, are still certainly a bit aware, maybe within 8 to 10 seconds to go back in and jump in the wheel. So that's the short spiel about iMotions.
Great, thanks, Peter. So in talking with some of you yesterday, one of the things that struck me was how powerful some of the inferences you can draw with the data you're extracting during experiential technology experiences. So I thought it'd be helpful just for the audience to understand some of that opportunity to have you describe maybe one or two of the most sort of powerful inferences you've seen people draw using these technologies.
Want me to jump in?
Yeah.
So I think we're limited here at RetNad within the scope of the VR headset itself. So you can imagine, maybe I'll just ask, who here has actually tried virtual reality? I can see you guys. Okay, wow. VR, wow, that's impressive. I wasn't sure if anybody here had actually, or if everybody here had tried VR. I guess after this tech, yeah. So within the headset, if you can kind of reimagine that headset actually as a scientific device, that's what RetNad's doing. We're looking at this as the most massively distributed scientific device in human history. And inside the headset, there's accelerometers, very similar to what's inside your cell phone. And these accelerometers actually give fantastic data off of body language, off the head movements itself. Your head movement when you're emoting in VR, based on assuming you're immersed, give these very cool patterns that we can decipher. So, or we're starting to decipher. So some of the inferences, not so much on the emotional side, because that's really difficult. I'm sure these guys can get into it a lot more than I can, because the head being one data point is limited, but it's still fantastic. So within the facial muscles, within the face, you've got these muscles that give off these very subtle reactions as well, which is fantastic in science to understand like how you're actually emoting. So the combination of all of these data points that are actually on your head that the headset can capture gives us a pretty clear path to behavior. Not quite emotion again, but this is the type of stuff that we're developing internally. So VR, again, assuming that it is immersive and you guys are being captured inside this environment, gives us some pretty incredible data.
Yeah, so what we do at E is a lot of people refer to us as the DVR for user experience. We're actually device agnostic, so we use neural sensing devices, motion capture devices, things like that. And we capture the entire user experience and the context around that for not only playback, but we also have built a rather large behavioral database that is powered by our machine learning technologies to do, in simple terms, pattern recognition, but fairly sophisticated feature detection. For giving an example, in an athletics use case, we're able to detect in real time when an athlete is performing a movement incorrectly and then alert that athlete via, let's say, a haptics response to correct that particular behavior in an effort to prevent the building of bad habits, which can lead to injury. So that's where we tend to focus, where we get a lot of inference and data. It's all about context and the overall experience, and that combined experience over time at scale from a large number of users is our hope that we can enable behavioral prediction long term.
Yeah, like I personally, I'm very curious about kind of like understanding emotions and kind of like doing those things. Well, kind of like other people like you, or you kind of like are way more focused on that. But what I'm really curious about is kind of like how can we change them? Kind of like how can we help someone who's not feeling bad? Because I can use those tools and figure out, okay, like I'm really stressed. Like then I put on kind of like biosensors to analyze them, and then the system tells me, yeah, you're really stressed. But what am I doing now? You know, like how do I get kind of like out of that kind of like issue that I'm having? And I think it really matters because like based on kind of like recent statistics, by 2020, like depression will be kind of like the leading cause for like deaths and disabilities. So we're kind of like as a mankind, we're like not doing better every day with all the technologies, more like the opposite that's happening. The same kind of like for rates with like ADHD that are increasing kind of like every year. Or in the United States, I guess it's currently 70 million that have kind of like issues with sleep and wakefulness. And personally, I think it's even more because literally everyone that I know at least sometimes has like issues with falling asleep or kind of like being tired because like, yeah, not sleeping enough and so on. So I really kind of like see a huge potential in all those technologies to address those issues in a scalable, affordable, and accessible way. Because like once I kind of like created a digital representation of something that can help people with sleep, I can kind of like stream it with billions of people kind of like for free. It's kind of like taking a picture, you know, of you down here, and those days I can put it on Facebook, and within kind of like a couple of seconds I shared it with a billion of people. So I see kind of like the biggest potential for that. Maybe it's kind of like stealing a little bit, kind of like from the transformative technology movement. If I sum it up, I'm really dedicated to use all those technologies to produce a positive change in well-being, where the understanding, of course, is also very important to kind of like see, if there's so many different techniques. There's different breathing techniques, different like meditation styles, and we are all different, and I think that's amazing. So there's like not that one kind of like technique that works for all of us. And I personally believe that that's where all those biosensors, no matter if it's brain-computer interfaces or like smartwatches, can come in to see, okay, what works for me and what just does not. Is it kind of like Mozart for brain power? Does it help me to focus just because it's labeled like that? Most likely it does not. Like we tested that out. But once we kind of like add like objective sensor data, and once we're kind of like capable of understanding it, we can kind of like teach technology to really guide us towards like a certain goal. It might be to sleep, it might be to kind of like reach a flow state, or it might be, I guess there's also a lot of kind of like meditative people in here. It might be kind of like straight going through self-transcendence, and kind of like persistent non-symbolic experiences or things like that. But for being able to do all that, it's key to teach technology to understand how we currently feel, to figure out, to kind of like teach my smartphone, to realize if it's what it's kind of like currently doing to me. Do I like it? Does it help me or not? And I think that's where.
Yeah, so I guess we're all sort of talking about what we've done. That is cool, so I'll follow that trend, I guess. But our mission really has been around how we make the technology pervasive. And so we're very interested and excited about applications of neurotechnology, which are truly mobile, pervasive, what we call like anytime, anywhere. There's been a trend in the sciences. I mean, the typical way in which you might measure your brain activity, for instance, is using a cumbersome EEG system. You're in a laboratory environment. It's very constrained. There's a lot of hardware involved, very not mobile. Now, what if I told you that you could have maps of your brain in real time, high resolution, on your cell phone or on a wearable smartwatch, and that important and meaningful information about your state that would only be normally obtained in a lab could be obtained on a little teeny smartwatch. And that can happen through the power of cloud computing. And so what I think is exciting about what we're doing is that our focus is really on cloud computation and how we make the technology pervasive. So an example is, I think maybe Adam this morning might have talked about, Adam Gasly, the glass brain, which is a project that we were involved in, where we developed a lot of technology for mapping your brain, mapping connectivity between different areas of your brain. It's beautiful and it's powerful. And back then we were doing this on GPUs this big. Well, you can do that on your cell phone. Actually, right now, if you go to brainviz.neuroscale.io, you can see a simplified version of that with one of the guys out there, where you can see his brain and navigate it in real time, the brain maps, the connections between his brain. You can go to emotion.neuroscale.io, and I'll check it right now and show you on my phone. So right there, we're mapping the valence and arousal state of somebody out there in the hall right now, as he's probably talking to someone in a booth. It looks like he's very deactivated, a little bored.
That's not good, man. You're not there.
That's
Yeah,
why you
not
should
there
come
to
in
pump
here,
him up. Now he's stressed. He knows what I'm talking about.
He heard you.
But you can all watch his brain right now over the web. You could ask somebody in China right now to go, and they'll be seeing an aspect of his emotional states. And again, this is a gestalt. We're getting there and trying to understand how these emotions work. But the point is, you can see this on a mobile device anywhere. And I think that kind of stuff becomes really, really cool when you start to think about what technology is going to look like in 5, 10 years when we're not carrying any computers and the technology disappears completely. It's the vision of ubiquitous computing, the vision that started at Xerox PARC back in the 70s, and we have not seen applied to biosensor processing, certainly not neurotechnology, for one, until I think now. So I'm excited about that.
Cool, man. It is exciting, for sure, again. So basically, we are a research platform. So I think I'm going to give a couple of examples of something that has been done with the platform. And obviously, it's not scaled yet into real-life applications. But we did a study, I don't know if anybody saw it, last year in Mythbusters. So we are at Stanford University, where we did a study on handheld versus hand-free phone. I don't know if anybody saw that episode of Mythbusters. Yeah, a couple. Okay. Yeah, okay, good. It's also died now, the series, so that's maybe why it's not so many people seeing it anymore. But anyway, what we did out there was we basically had one of the world's most sophisticated driving simulators, so we can, through the platform and the API, basically take all the data from either the CAN box in a real car or else from the simulator, where we basically take in the steering wheel, brake, throttle, and so on into the platform and live visualize it. And then we had all these, basically all the drivers went through a course, and there was people running out in front of them, a bike coming out here and there, and so on. Basically everybody killed somebody, unfortunately. So really the conclusion for that study was pretty interesting, and that was that it's actually equally dangerous, even though you think that, when you drive around with a hands-free that you're all good when you drive your car. That's actually not the truth. There's no statistical difference from actually sitting and using one hand holding your phone. And obviously that's pretty important information, and you have so much cognitive workload going on when you have a discussion with somebody, that it's basically you don't focus the right places and keep an eye on traffic and kids running out on the street. So that's a concrete little case. I think a couple of other things that's worth mentioning. There's so many cool things going on. One thing is like the future is basically that you will be screened sitting at home, talking to an avatar, and it could be in VR, but also just sitting on the computer. So basically we poured in all these different kind of technologies to look at all the different parts of your body, both the face expression, we talk about eye tracking, GSR and so on, but also voice analysis. So basically, the future, diagnosis for you for depression and these kind of diseases, you basically sit and talk to an avatar. And basically, what happens is that you can, through the API, shoot all the data from a Unity avatar, for example, into our platform. You can do the live processing in there, and then basically we live export all the emotional responses from the person into the Unity environment, for example. And then basically this avatar has, through machine learning and so on, basically they can hear, where you're uncertain in your voice and all that, and ask the right questions to try to dig deeper through the rational layers. So that's some of the stuff that's going to happen, within not too many years. We of course have a lot of going on as well in the diagnosis of neurological diseases, which is a big passion for me. My mother died of Parkinson's, so it's been very close to our family. And basically, with Alzheimer's, for example, as well, there's going to be a lot of technologies that can help diagnose these diseases. So that's just a few of the examples. I have another 200 examples, but we have maybe thousands of projects going on right now. And what we try to do is just to make all these researchers realize their dream, and also all the companies making sure they deliver better products, more safe products. So it's pretty exciting and really concrete stuff that's being done out there.
So we've talked about some of these technologies can do. I'd be curious to hear what sort of misconceptions you find people have and misunderstandings about how these tools can be used.
I'm going to pass, so we're not going down the line the time. I'll pass off the baton to somebody else. Finish with me.
I can start if you want,
Yeah,
but I just talked, so maybe you should do it.
I have a long list, so maybe I'll let you start.
I have a short list. So for us, one of the main misinterpretations is that people think it's extremely complex to collect data with all these devices. And obviously that's the pain that we have tried to solve for 12 years now. So that's really the biggest misconception we see when people come out and see all this stuff being streamed live into the platform, make it possible to slice and dice the data and really take things, into a cloud-based solution or into MATLAB or R. It's extremely simple now. And we can basically train people within an hour or two to begin to conduct these kind of studies. So we go from shifting from that you had to have a PhD in computer science down to even being a bachelor or undergraduate, want to try to play around with sensors and understand human behavior, see things work on themselves, how we're reacting as people compared to a stimuli. That's the biggest misconception. So it's there, it's now, it can be done.
Yeah, absolutely. I mean, and that would actually be one of the things that I would definitely resonate with. Going again from having to basically bake your own cake, have your own recipe that you put together yourself, to being able to use off-the-shelf components. It's been extremely transformative. I would say there's also there's two other things. I mean, one is this notion that maybe this group doesn't think this way, but outside of this group, the notion that, say, things like EEG, that they're venerable dead technologies that come from the 30s. Why would we want to use that? There's fMRI, there's MEG, these big, expensive technologies. Aren't they that much better than, say, EEG? Yes and no. There's things that you can get from an fMRI machine that you cannot get, the spatial resolution being one of those, but you will never get with EEG. But on the other hand, there's so much of a gap that can be closed with these kinds of technologies like EEG, which do come from the 1930s, but can be applied in new ways. And there's still a gap in terms of understanding the information that comes out of the brain through those types of systems. What's amazing is that we've had this technology for almost 100 years, And we're still just starting to make sense of what the squiggles mean. And a lot of the ways in which we analyze the data now is like it was done back in the 1930s, looking at the squiggles. That's all changing now. You know, machine learning is becoming ubiquitous and all kinds of new feature extraction methods. So I think that's one of the misconceptions that I'm really excited about seeing that paradigm change. One of the other misconceptions, I think, is a little bit on the other side, and it's something that I think may resonate with everyone in this community, and that's the idea that technologies like, say, EEG and BCIs can read your mind, for instance, that you'll have a thought translation device in 5 years where I just think a whisper in my head and it's bam, it's decoded. We're not there yet. And as scientists, we always kind of push against this notion because you always get that like, oh, you scientists, you've figured it all out, right? You know, you can read the mind, great. And then there's all the people saying, oh my God, they're reading my mind, is NSA reading my mind right now, And so I just want to always put that out there, that mind reading is not here now, but it will be here someday. And actually, maybe you'll talk about ethics and privacy, and then we have to start asking questions about what will happen in society when we are able to do that, because it will come at some point, just not today.
Yeah, but it's so funny that you mentioned that, because like most of the people can like, no matter which BCI we use, can like not so much here, and kind of like not like skilled people, kind of like, but for the vast majority, it's like people, oh my gosh, like now you're reading my mind, like, stop it, like you're not supposed to be in there.
That's my private thought.
And I also think kind of like in general, kind of like with determining emotions, well, the more modalities you have, the easier it becomes. But on the other hand, I think it's also not that black and white that you can kind of like exactly say, well, like on an absolute scale and kind of like those 7 dimensions, that's exactly where you are. Maybe if you have kind of like just like a GSR sensor, I could be incredibly excited or incredibly anxious. This is kind of like a profound difference, and maybe without like any additional modalities, I don't know like where I am.
Right, absolutely.
I think another kind of like misconception is maybe it's more like a human thing. I've not seen that here, and that's what I really like about that conference, about the people here. But kind of like at other places, that a lot of people kind of like try to do everything kind of like themselves. And I completely agree, like based on the tools that we create and others create, it becomes very, very easy, push button easy, but it's still, if I go from a sensor all the way to an experience, there's like so many kind of like different people involved. There's like a signal processing part. Then I might have kind of like a neuroscience part. Then if I want to create an experience, like I might have kind of like a background sound. That needs to come from someone. I might want to have kind of like a storyline that might come from someone else. Then I might want to have virtual reality. Like someone needs to create that. So I think there's a huge opportunity, but it's really a collaborative aspect. So to really make all that happen, I think it's kind of like what I'm talking about. It's kind of like the ecosystem. It's kind of like required. From kind of like figuring out what works, kind of like on the testing, analytics side, over kind of like the middleware from like devices till the application, then still kind of like, okay, what happens in the application, how it looks like, and so on. And I've seen some people, I don't want to say failing, but a lot of people tried, I have all those tools, and kind of like at night between like 2 in the morning and 4, I do kind of like the vocals myself, and then I think it's a common thing. It's not like a misconception. It's just like here, like in the neurotech industry or experiential technology industry, it's just like maybe more like a human condition. Some people are more collaborative, and some are not so much.
Yeah, so I would say with the challenge that we have being sensor agnostic is when we describe what these sensors are capable of doing to potential customers, potential users, they immediately begin to attribute expectation to what they can then do with these sensors. So what I'd love to see over the last 5 to 10 years is that we are starting to apply real use cases. So users don't think about accelerometers and gyroscopes. They don't think about those things. They think about what the technology holistically can provide to them in regards to a solution. And that's the biggest challenge, the biggest misconception is really just an expectation that we have to our expectations that we have to provide to these users with real use cases that solve problems. And you'll find that a lot of these misconceptions, they'll vanish because people, they'll have a language that they can apply to a solution rather than thinking about the sensor itself. And that's one of the greatest challenges. And a lot of us that are in the industry are working together to solve. So we don't really have any misconception issues anymore because the expectation has been set.
It's funny, I'm guilty of promulgating one of those misconceptions. My wife asked what the panel was about, and I said they read your mind with applied mathematics.
Well, it is a simple way to convey. And I do want to say there's amazing things you can do. I mean, it's astounding how far the field has come and what we can do. But from that to a thought translation device, the idea I can hear the words in your head, that's a gap that is not there. And probably it's a good thing that we can't hear your inner conversation right now, Josh.
But I like that you keep the mystical part,
Yeah, it'll be interesting to see that applied in the political sphere.
Neuropolitics.
Yeah.
It's a real thing, actually.
You should do that at Emotions. Like hook them up, like at a debate, kind of like
I mean,
real,
especially
like,
this
violent
election.
analysis.
Can't get into politics on a panel.
It might be getting done.
What?
So actually, that's one point that I have is like what we see out there now. You can actually combine so many modalities, and you're right. Huge, massive data is not necessarily the solution, but now you can actually get it, and you can get it synchronized, and then you can go back to the, that because you have had EEG for so many years, there's so much old knowledge about it. You basically, what you can do with the more non-intrusive technologies like eye tracking and facial expressions and the smaller devices for GSR and ECG, those four modalities in combination, what a lot of people is trying to do is to really see, hey, can we replicate some of the stuff that we know with EEG so we don't need to wear a big helmet with gel and all that, and then have it out in real life where it can scale much more and really be a solution for customers and for consumers.
Yeah, that kind of gets to another question I had, which is like, why now? If we've been looking at squiggles since the 1930s, it seems like something is different in kind now in terms of what folks are doing with those squiggles and some of the other data that we're gathering. So what changed? We've had VR in some sense since the 1990s. I remember strapping a CRT tube to my head essentially in an arcade. So why now?
Yeah, it's a great question. I think, why now? I mean, maybe a little pragmatic answer is because the technology's here. I mean, it's impractical to strap a CRT to your face, right? I mean, Virtual Boy was one of the first forays into virtual reality, and that just was a massive failure. It was cool to see, and there's still a lot of that thought even today. I mean, I think you're asking why now. I can't really answer and say, well, it's here now or it's not here now. I think it's still a question that will forever loom over the technology until it just kind of is and exists. So for virtual reality, the why now is, are we immersed? And that's what I was getting at before is, are we immersed right now? And I think a lot of people in this room that have tried, so I was surprised from the answer. 3 months ago, many people, I don't know what happened, so many people had just started dabbling with VR. So why now is the feeling that VR can finally be this immersive technology. And can actually convince us that we are somewhere that we're not, just by putting on this headset. And there's still the screen door effect. So for all of you that have tried, you kind of get this pixelated effect because you're cramming again. Now, it's not a CRTC, but you're smashing generally a phone against your face. Or you've got the Oculus or the Rift that's tethered to a computer with a really powerful graphics card, but you still kind of get that screen door effect. So we see in something like 36K, and we're at like 2.5K. So the processing power that's needed to get there is incredible. So I think why now is because the technology is good enough to sell to us, and it's a compelling piece of hardware that can transport us somewhere else. And that's, again, from the VR perspective. But I still think it's a great question that in the VR industry we'd actually need to be, we are asking internally is like, okay, why now? And how do we actually get to now? And that makes sense.
For us, that allows us, enables us to do what we are able to do is automated computation in the cloud. So with the rise of HPC, GPUs specifically tasked with processing these humongous data sets is something that was commonly done in research facilities in the past. It was and it still is to a certain extent, particularly with bleeding edge research, it's done very manually. So if you were ever a research assistant where you were crunching that kind of data, we can very rapidly today train over a very short period of time, especially with scalable HPC backends, to enable these machines to learn how to compute agnostic sensory data autonomously and really automatically in the cloud, so that when we're building services, applications can take advantage of those services, and there is absolutely no overhead when it comes to low-powered, fairly incapable devices. In many ways, we think in the terms of AR and VR. When you think of, let's say, NVIDIA Grid, and many of the technologies where you can do rendering in the cloud and simply stream that data using common techniques, let's say HTTP live streaming, that's been very common on devices, on iOS and Android devices in the past, combining that with extremely low latency. We may not necessarily have to provide GPU scale power in mobile devices if we can just do all of the graphics rendering in the cloud. So it's ultimately just automated computation in the cloud at scale.
Yeah, I completely agree on that. Kind of like one of the wisest, because we are now able to, like computing powers are kind of like really got good enough. Algorithms got better now. Smartphones can do it. We all have smartphones. On the other hand, you know, like I guess like decades back, like EEGs have been out there for quite some time, but in laboratories and in hospitals, and like thanks to Muse, like now there's all the Best Buy, you know, now it's kind of like a consumer product. Like there's watches kind of like on people's wrists that now kind of like measure all different kind of like biodata. So we finally kind of like see all those kind of like sensing technologies, wearables, hearables, etc., they made it to consumers. We have the technology, and like the other hand, the why is, I think, because we really need to act now. Like if you look at the statistics that I earlier mentioned, it's not getting better. So we really, and we all get it. So I think it's really kind of like our duty to just like collaborate and produce a positive change.
Yeah, I mean, I resonate with this idea that why is coupled with, you know, having a capability. And I think, you know, if you look at, you know, film and media, I mean, we've been talking about mind reading since, you know, the 50s and earlier. And it's, you know, pervasive in science fiction. But the technology is now enabled. That's computing, and that's hardware getting cheaper, faster, and a lot of that's enabled by other domains. Mobile technology, gaming is what's really powered the entire computing industry forward. So thank God for VR, because I can't run on my normal laptop right now a VR experience. That means we're going to get a new generation of even better GPUs, and we love to use those GPUs for our computation on the cloud. But so I think that's part of it. But I want to say something specifically about neuroscience. There's been a paradigm shift in the neurosciences that is actually, it's preceded the shift that we're seeing in the consumer world about neuroscience being about neurotechnology, but it's very much interlinked with it. And you know, neuroscience is like the brain is the last frontier in some senses. We feel like we understand how the outside world works now. We feel like we've mapped out physics pretty well. You know, quantum mechanics is still a fuzzy domain, but the brain is still this mystery. And now we finally have the tools to start cracking that mystery. So just from a purely kind of phenomenological perspective, humanity is extremely hungry to understand how this organ works. And we know that it's incredibly important to our experience, to everything. So the fact that we now can study it, coupled with that great appetite, I think is one of the major things that's propelling this huge appetite in the consumer world, in the medical world, et cetera, for new neurotechnologies that can solve that kind of problem and close that gap. The one little thing I would point out is when we ask about why now, I think it's important to think about where we are. We ask about why is VR important? It's important to think about why VR is important to us here in America and so in Silicon Valley. But if you go to India or you go to South America and you ask somebody, why is VR important to you? And they'll look at you with a very blank stare. And so I think one of the challenges, maybe this goes back to a challenge, one of the challenges is to find ways in which we can make the technologies that come out of our industry applicable globally, make this stuff useful for people who are outside of our sphere. And there is utility for that. But anyway, yeah.
I just have two sorry?
I'd love to just answer or just respond to that really quickly. So VR, actually, you're absolutely right. Like, who cares outside of Silicon Valley? In China, they're finding there's a huge market for this because people in small box condos or small box apartments that are really depressed will put on this headset and all of a sudden their apartment goes from like 3x3 to like 400 by 400 or unlimited.
Right.
So why now is really important for different markets. But you're absolutely right.
No, and that's an amazing example right there. Yeah.
So yeah, two small things. I think on the research side of things, the more higher end devices that are out there for GSR and ECG and so on, obviously can do something that you can't get from a Fitbit and Apple Watch and all that. They're not there yet. So they get a lot smaller and cheaper. So we really see that whole market drive pricing on hardware for eye tracking, all that stuff is really, really, something that has made it from $100,000 investment down to maybe like between $20,000 and $40,000 investment. So that really means now that the second thing is that we really see the corporations, the large companies, they're investing heavily now into understanding human behavior. Now when they can understand all the different modalities, we really see a big difference over the last 4 or 5 years. There was a lot of tire kicking, okay, exciting, does it work, okay, and they want to have a lot of information. Now they are buying and they're investing heavily in building also global labs, large corporations having like 50 or 100 labs across the world where they can gather all these consumer data. So that's the two things that I think is happening as well.
It was interesting to hear several people mention GPUs. Some of you probably saw in the news today, Google admitted to having a custom ASIC for machine learning. They're calling it their tensor processing unit, and they claim that it's about 7 years more advanced than what we can do with GPUs. So folks using TensorFlow, for example, in the cloud for some of this are evidently have been running on this for a year and not known it. Which sort of leads into my next question, which is what are we going to be able to do, say, in 3 years from now that we can't now? Like, where is this going?
Well, yeah, so I can tell you what I think. So I think definitely you're going to be very close to going down to the doctor, and you're going to sit in front of a screen, and you're going to be screened. You're going to have a set of standard stimuli that is maybe some videos, maybe some images, and something where you have to interact and also measure some reaction times. And you're going to be able to actually, on neurological diseases, to say, hey, this guy is in the category for Alzheimer's or Parkinson or whatever, and you're going to be able to take these people and examine them deeper. So I think these screening tools, they're going to come very soon. Post-traumatic stress on soldiers. If they're out in Afghanistan or Iraq or whatever, they come home and they become very depressed and they kill themselves. Unfortunately, that happens a lot, as we know. But it already happens out there. That's already when their brain begins to act in a different way. So with these systems, they're very mobile. We can actually bring them out into the tent out there, more or less, and let people look at a battery of stimuli and be able to help see if we see some less emotional response based on all the things they have experienced. And tons of other stuff, but I don't think we have time.
Yeah, I mean, I would just add to that. I think that's a great example. One of the things that I think is going to happen in the next, maybe not 3 years, but 5 years, 3 to 5 years, but definitely we'll start to see a lot of this within the next even year to 2 years, but also 3 years out, is as these sensors get out there and data starts being accumulated. I mean, one of the big challenges in the brain-computer interface domain or neural interfaces in general is generalization of models. So the ability to basically have a decoder that I don't need to have it doesn't need to have any specific data from me. It works based on other people's data and applies to me in a variety of different scenarios. So let's just take emotion. If I want to be able to put a sensor on your head and say what your emotional state is when you're at home, when you're at work, when you're cycling, all these different contexts, I need to have a lot of data to be able to look at all that variability. And we're now at a point where it's completely 100% feasible to do this now, to aggregate this data, to mine it, and to build what we call zero training decoder models or classifiers. And that is going to completely change, I think, a lot of the ways in which we use neurotechnology. It's like the shift from when, I know you guys might be familiar with Dragonsoft. They have this sort of naturally speaking, right? And you used to have to spend day after day training these speech models. Now it works for you. I mean, Siri or whatever, you just get it and you say something and it knows. So that's because it has a lot of data to work with. And so I'm really excited about that. It's going to happen very soon.
Yeah, I really look forward, I also don't know how long it takes, but to see technology really helping us to evolve, to feel better. Because I think a lot of the issues have been created by technology, and I really think it's time to flip it around and use it in a more helpful way. And what you just said, that you're sitting in front of a screen, that you're being diagnosed, but I really see the potential for technology to be even more on the preventive side, just to keep us healthy. That we're just maintaining a more balanced, more happy life. And on the other side, of course, it can still help us once we can freak out, once we can have issues with emotional needs or get into burnout, depression, and so on. But I really can see the potential. Also, what you mentioned, that it's more and more ambitious. We don't even realize it, but our phones and like computers become kind of like clever, get us more, it might maybe just like don't show us an email that would like seriously stress us out when it realizes, oh my gosh, like it's at the end of the day, there's no way he can solve that problem right now, so why should I send him or show him that bill right now? I can do that tomorrow morning. So to also kind of like get a little bit more towards that direction.
I would pay so much money for that.
Yeah,
Filtering my
but
email
it's
based on my
completely
emotional
doable,
state.
It is. And I mean, if I could just add I know we're doing a linear back and forth ping pong, but to add to, exactly just to augment that a little bit, but one of the things that's really exciting is mashing up tools that already exist to try to do that. Like Google has some Inbox, for instance, tries to compose responses for you, on the fly. They're actually remarkably not bad. These are little short
really
canned
good.
responses. Yeah, I'm surprised. Yeah, that's using deep learning, try to mine a whole lot of stuff. But imagine you augmenting that with Neuro Technology or with other data about the person. So this idea of being able to mash up different sources of data, that now we have the ability to plug together all these different sources of information, and you start to build a much better picture of a user that way. So that's exciting.
And it's being built right now, just interject quickly, it's being built right now by a company called Rival Theory in VR again. So for those of you who have seen the movie Her, where there's that little character that kind of curses at the protagonist, this kind of AI character that says, oh, how are you feeling today, and so on and so forth, that can interact with you. That is on its way in VR. So it's all that, Siri, what's the next foray of Siri? And VR, I think it's AI. It's this character that looks at you and goes, oh, okay. Not only responds to your emotional state, responds to how you're physically feeling right then and there in real time, and says, okay, cool, let's dynamically change the environment around you based on how you're feeling right now. So if you're sad, it's like, okay, let's get a pick-me-up and change this thing. So I think that's the evolution. And
when smart products really become smart.
Yeah, exactly.
Right, exactly.
Yeah.
Yeah, that's essentially my response. So sensors are going to be more and more pervasive, higher resolution, greater depth. Where we're really interested in this kind of movement is providing context to these sensors. So in the next 3 years, we're going to see a large population on Earth that has a fairly intimate, and you're already seeing this now in a transparent way, but there will be more of a bidirectional communication with bots. And that's primarily what we focus on, is the creation of AI bots that specifically focus on the not only the processing of all of this information, feature detection, and things that you would find common in machine learning, categorization, all of that, but also providing a human interface to collect data at what we call abstracts that can then be tied into this more holistic temporal context that really gives definition to all of this sensory data, and going to more abstract, more generalized models and things like that. So there are several companies out there now that you provide a data set, one click, and they suggest the appropriate model for those data sets. So we're going to see a lot of that automated longer term. That problem will essentially go away, but we still have that human interface that's required to provide context to all of this massive data that we're collecting.
Great. Well, I think we're probably running over. So thank the panel. You guys knocked it out of the park, and it was fascinating as I expected it would be. So thank you very much.
Thank you so much.